Hello, this video shows you a printing of the cube you are going to preview in TD1, and it was recorded in INSA in a distance device. The workpiece is a cube, but we need to print the attachment to the plate that is just below together with the piece. So it turns into this geometry that we are going to print. The equipment that we used is a UTMaker 2. The filament is behind the machine and the filament passes through the head. The printer is connected to a server, and then the server is connected to a device called OctoPrint. So this is the window of the device, and we can see the temperature, the control, the G-code viewer, and the terminal. In the window for temperature, we can see two curves that shows a red curve that is the tool temperature, and the blue curve, the temperature of the bed. So in the curves of the previous printing, we can see that the temperature for the tool should be at 200 degrees Celsius, and the temperature of the bed was heated until 60 degrees. Now the temperatures are 31 degrees for the tool and 37 for the bed. So we need to heat it before printing. First of all, we need to open the file that we produced in UTMaker Cura, the software that opens the STL code and adapts to the requisitions we have made for the printing. Then, this is the file that was uploaded, the cube file. Then we are going simply to print. For printing, as the device is connected to OctoPrint, when we put print, we'll send the program. We'll calculate the approximated time and we'll begin the process of printing. The process begins by changing the temperature, the target, to the bed, so heating the bed. You can see that now there is a straight line. This straight line is the target, the 60 degree that the bed should heat. We can see that the bed begins to heat and the tool keeps the same temperature because the target didn't change yet. In the camera, we can see that the bed is the lower part and the tool is in the upper part and didn't move yet. In the terminal viewer, we can see that the temperature is getting up. It takes about 2 minutes for heating the bed, and it takes less than 1 minute for heating the tool, the head. You can see in the curve. So after the head is heated, the bed will come up and then the filament will be purged in the corner of the plate. We will see when it gets heat, the filament will drop down and then the head will come to the corner and the plate will come up. It will purge and then it will begin the printing. 3 minutes for heating. The first layer is the attachment to the plate. In this case, bring. So we can see the G-code viewer, the trajectory for printing the attachments to the plate. We also can see the G-code with G1, X, Y, and the trajectory that the control is showing. The temperature is correct, 260 degrees for tool and bed. And the printing, we can see the printing of the bring, and just after, the printing of the workpiece in the internal part. We have 4 minutes of printing, and then we are going to finish the first layer that includes the bring. Next to that, we are going only to print the layers that contains only the workpiece, the wall around, and inside the filling. In this program, we can see that the black lines are representing the trajectory where the tool deposits the filament, and the green one, the displacement only. We are getting to the end. We can see that there were 14 minutes for only printing. We can check the G-code viewer for the last slice. And also we can check the terminal to see that actually it's cooling down. And then now the temperature is dropping, both the head temperature and the plate temperature. As in the beginning, the inertia for the plate is bigger, so we have more time for cooling the plate than the head. When it finishes, the plate goes down. I'm moving down with the arrows. And then we can take out the workpiece from the plate. After the plate has cooled down, we can take off the workpiece. And that's it. Thank you for your attention. See you soon. Bye bye.